The title of my project is Emotion Detection Singing Voice. In fact, it should be the usefulness of speech quality measures in identifying emotional content in singing voice. It is such a long title and confusing, but I will explain it in detail in the following presentation. And my name is Lin Wang. My email address is linwang@ufl.edu. This is part of the frame of all the work should be done in the field of emotion detection. The highlight blue part is my part of work in this project. We can see that basically the entire frame includes three parts, which are feature extraction, audio database, and machine classifier. In the part of feature extraction, I chose some of the features in the branch of speech quality features. And my database is singing database. We can see that there are also some other kind of databases, such as speech database and music database. Singing is a combination of speech and music. The last part of the frame is machine classifier. For the classifier part, I chose hidden Markov model HMM as my classifier to cluster the speech quality features extracted from the singing database. And finally, I will get out results. Here is the achievement of my project. It includes three parts. One is the database development, then is feature extraction, and finally classification. In the database development stage, I invited three of my friends who are professional Beijing opera singers to record the singing database for me. They are respectively female, male, and Nandan. Nandan here means that male singer acting like a female one. Here I tag it as a transgender or simply trans. Next is the feature extraction part. I select three features which are jitter, shimmer, and HNR harmonic to noise ratio. I extracted these features from the singing database. And the final part is classification. I use HMM to train and test all the extracted features from singing database to see whether they are applicable or not. Okay, this is all the achievements of my project. Now let's come into the background part. In this part, I draw a flowchart of emotion classification of my project. It basically includes three parts. One is database development, then feature extraction, and finally classification. In the classification results part, it includes the training, the testing, and I will get the classification result. Now let's come into the first part of my project, database development. As I have said before, I invited three singers for me to record some music. They are Beijing opera singers, so my focus is Beijing opera database. They are tagged female 01, male 01, and trans 01, with negative and positive emotions respectively. In total, there are 77 samples for negative emotion and 57 samples for positive emotion. This is the database of my project. Next is the feature extraction stage. In this stage, I extracted three features from singing database, which are jitter, shimmer, and HNR. Jitter and shimmer are two similar features. They are the vibration of voice signal. Jitter is the amplitude of the vibration, and shimmer is the frequency of the vibration. I extracted these two features from the software of Pratt, which is a useful and powerful tool to extract features from audio in a relatively easier way. With Pratt, I got all the jitter and shimmer values of the singing samples. The left column is the name of each sample, the right column is the corresponding value of jitter or shimmer. Next is the harmonic to noise ratio. This is the hoarseness of voice. Here is a picture for the HNR result of one sample. You can see that the horizontal axis is frame number, and the vertical axis is the corresponding HNR value of each frame. For the reason that this is the feature with a frame-by-frame result, I need to calculate out some single value for each sample in order to put this feature into the classifier. As a result, I keep the max value and the median value of all the frames for each sample. Now let's come into the classification stage. In this stage, I chose the hidden Markov model as my classifier. This model is a kind of Markov chain. Although this is a kind of process that we cannot observe directly, we can do that from some other related states, which is generated by some probability distribution states. HMM is also a double stochastic process. In the training process, I train the three features respectively with positive and negative motions, so that I can use this trained model to test out the features in the next stage. Now here is the classification result of all the features. This is the cluster result of jitter. You can see that the left column is the classification result. Neg means that the negative sample was classified as a negative sample. Neg-pos means that the negative sample was classified as a positive sample. Therefore, neg and pos are two successful cluster results. Neg-pos and pos-neg are two incorrect clusters. And the numbers in the table is the corresponding percentage of each cluster. In this table, there are three successful clusters has a value of about above 80%, but there is also a cluster has a value of below half of all the samples. We can see that there is only one cluster has a low percentage of success and others are relatively high. Next is the cluster result of Gima. There is a really low value of success for the negative emotion of female 01, and others have much higher percentage of successful cluster. Next is the mass value of HNR. This is a really good result for the reason that I got one cluster with 100% correct cluster, and the percentage of the all other successful clusters are good enough. And the last one is the cluster of median value of HNR. This is probably the best feature to be used to emotion classification by now. There are three clusters with 100% success. It is amazing. These are all the results of the classification. Now it is the conclusion part. We have noticed that the confusion percentage of most of the cluster result is below 35%. There are also some of the cluster result has a confusion percentage of about 0. It's really cool, and there are also about two clusters got a confusion percentage about 50. But it is also acceptable. What we can do in the future is that we can strengthen the database for future research, for the reason that the database I already have is really small, and I should invite more professional singers for me to record more singing samples. The other thing that can get improvement is that I can choose some other features and classifiers to make different combinations of them, so that I can compare which feature and classifier set is better than others for a specific kind of emotion. The last thing I want to mention is that emotion classification of singing voice can be not just about positive and negative. It can have some more various kind of emotions as that of speech. I can also do some more research in this part if I have time. Okay, this is my project. From the introduction, background, to feature extraction, and then classification, and finally is the evaluation, conclusion, and future work part. Thank you for your attention. Next, I want to demonstrate my programs. I use Pratt to extract jitter and shimmer values for the database, for the reason that jitter and shimmer are not that easy to calculate by MATLAB through formula, and with Pratt, I can extract it in a simpler way, with only press some buttons, reading data, and input arguments. This is a really cool software for the research of audio, but for the reason that there are more than 100 samples, I cannot calculate jitter and shimmer values by pressing the button for each sample. It is really time consuming. Therefore, I learned the script from the website. In order to make this program to run intelligently to read in data, calculate the value I want, input the argument necessary, and finally save all the results in a text file. So I can open my script. Here is the script for jitter. With this program I have written, now I can calculate jitter and shimmer values automatically instead of by hand. And for the program of shimmer, it is really similar. And next, about the feature instruction of HNR, here is the program for HNR. I implement this with MATLAB. This is kind of simple for the reason that there is formula for HNR which can make work more straightforward than that of jitter and shimmer. And finally, about the classification, I use the HMM toolbox. Here is the toolbox of HMM, and I made some adjustment to let it fit into my project and get all the results I want. Okay, this is my project with a presentation of the slides and demonstration of my code. If you have any questions, you can contact me by email. My email address is linwang@ufl.edu. Thank you for your attention again.